This is a quick video on how to solve a system of equations involving 3 variables and 3 equations. So in step 1, you're supposed to look for a variable that can cancel out. Try to find a variable that is fairly easy to cancel out. Like, look for variables that already have the same number but opposite signs. For example, in looking at this problem, you might look at and see that these right here are already not only the same number but opposite signs. So we can use these two equations here to play out elimination. So I'm going to add the bottom two equations together to cause my y's to eliminate. Now what that does, I add straight down 4x and x makes 5x. 4z minus 1z is 3z. And 19 and negative 20 make negative 1. Now, what we want to do is, now that we have a 2-variable system, we need another 2-variable equation. So what we need to do is do elimination again of the same variable but 2 different equations. So I can't use the second two I can't use these equations here and here. I can't use these two. I do need to get rid of the y again, but I can't use these two. Now I can use this one and this one, or this one and this one, but I just can't use these two in combination again. So if I decide to use the first and the third, because I noticed that the first and the third also have the same variable but opposite signs, I can use the first and the third for my second equation. So I'm going to add those straight down, which will cause my y's to cancel again, but just keep in mind I'm adding this equation and this equation. Now what you'll notice here is that the negative x and the x also cancel out. Now this doesn't always happen, but sometimes it does. And then all I have is my z's. So negative 5z and negative z is negative 6z equals 2 and negative 20 is negative 18. Now, you could just solve for z right here. As I notice, I can solve for z because the z is already by itself. But we're going to play this out like we're supposed to and assume that we don't notice that happens. So I have 0x minus 6z. Now that I have a 2-variable system here, now I can perform elimination again to try to get one of my variables to cancel out. Now what I might notice here in this one right here is that I could make the top equation a negative 6 by simply multiplying by negative 2. Okay, which would give me negative 10x, not negative 2, positive 2. Oh, silly me. Okay, let's try that again. I need them to cancel, so I need them to be the opposite sign, not the same sign. So 10x and then positive 6z equals negative 2. And so now I'm going to work with these two equations here, noticing that my z's cancel. So add straight down, 0x and 10x makes 10x. These z's cancel, and negative 18 and negative 2 is negative 20. Finally, I can solve for one variable because that's all I have left. So my x is negative 2. So let me just wrap this up sort of in summary here. What we needed to do initially was to look, because we have 3 variables and 3 equations, we have to cause one of our variables to eliminate twice to give us a pair of 2-variable equations, and then we can use our skills in doing elimination there to get it down to 1. What you learned in the previous lesson is how to do these problems, 2 by 2s, or 2 equations and 2 unknowns. So what we just need to do is get it to this point. We did that by getting rid of the y's leaving us with x and z. Then we chose two different equations to get rid of the y's again, leaving us another equation with x's and z's. That way, when you have x and z twice there, you can just use two variable elimination to get it down to 1. Now, once we get it down to 1, we sort of have to work our way backwards. We start by putting our newfound value here of x negative 2 back into the 2 by 2. And then once you have it in a 2 by 2 and you have two answers, you'll put them both in the 3 by 3 to get the third answer. So let's work our way backwards. We're going to plug this into, the only place that I can put this into with x is the first one. So I'm going to put this in there in the first one. So what this is it's 5 times negative 2, because that's x, plus 3z equals negative 1. 5 times negative 2 is negative 10. Let's see here. Equals negative 1. I add the 10 over, plus 10, plus 10. So I get 3z equals 9. Divide by 3. And z equals 3. Now that I have two variables, I have my x and I have my z, now I can plug both of those into one of my three variable equations. And it doesn't matter here. It's whatever you want to do. I'm going to plug it into the middle one just to make this easier. I'm going to highlight this. I'm going to plug it into this one right here. So 4 times my x, which is negative 2, minus 5y, plus 4 times my z, which is 3, equals, I got to slide over, 19. 4 times negative 2 is negative 8. 4 times 3 is 12. So I have, now let's sort of zoom in here, or zoom out actually. Negative 8 and 12 is 4, so I have negative 5y plus 4 equals 19. Then I subtract the 4. Negative 5y equals, that's a y, equals 15. Divide by negative 5, divide by negative 5, and you get y equals negative 3. And there's all my answers. I have x and y and z. If you'd like to, please replay the video to go back and see where things happen. Basically, now your final answer gets written in the form of these braces that I, holy cow, can't draw. Let's try that again. There you go. Negative 2. You got to go x, y, z. So negative 2, negative 3, and 3. And that would be your answer right there. Thanks.